Hello guys, welcome to today's video, and in today's video we are going to solve logarithmic equations. Okay, so this session is going to be very interesting. Okay, so first of all, I would like to ask you that what is the need of solving the equation? Okay, now what happens is that when we solve equation, the main aim of solving the equation is to find the value of the variable, right? So what's the primary aim of solving the equation? So solving equation, it means finding the variable. Okay, finding the variable. So a variable, it can be x, it can be y, it can be z, right? Or any or it can be represented by any abstract symbol. Okay, so whenever you are asked to solve the equation, it means that they are asking you to find the value of the variable. Okay, so um, I have selected some questions for you, and we are going to solve it together. Okay, so let's start with question number 1. Okay, but before we start this, I just want to say one thing to you. Okay, the properties of logarithm that we did, basic properties and the principal properties. Okay, you need to remember all those properties because uh, in you will see it later. So when we are going to solve the question, you will find that in many stages while solving the problem, we are going to use the properties. Okay, so if you don't remember the properties, then you need to go back to your notes and you need to pick it up. Okay, so better you remember it and you can use it for long. Okay, so let's start with the question number 1. So question number 1 says that log x to the base 1 by 3 minus 3 root of log x to the base 1 by 3 plus 2 equal to 0. We have to find the value of x. Okay, now if you look at this equation, okay, see here how to approach this problem. Okay, now if I look at this equation looks very simple to me, except the thing that I have this complex term here in this equation. So if I can do something about this complex term, it means that I'm on the right track. Okay, now see here what we can do about it. What if we assume this complex term to be something, okay, or we substitute this complex term with some variable? Okay, now see here, substitution, it's a very important thing in mathematics, or we can say that it's a makeup of mathematics. Okay, so whenever things gets messy, or you may think that, oh, it's a complex problem, but then if you put substitution into the practice, then you will see that, oh, the things are getting back to the right place. Okay, so here this term seems a bit complex, so in order to make it look easier, what I can do here is that I can uh, put log x to the base 1 by 3 equals to n. Okay, so I assume that this is n. Now what happened? This will be n minus 3 root n plus 2 equal 0. Now see here, now this looks quite simpler compared to this one. Now, what I can do is that here I have under root, so I can just bring it to the other side. Okay, so if I here, what will be left? N plus 2, and here 3 root n. Now, I have to get rid of this under root. Why? Because I need to find n, because see here, in this equation, we are finding x. To find x, we have to find n. So, to get n, we have to get rid of the square root. So, I can say here, squaring both sides, we get here n plus 2 square equals 9n, and here would be n square plus 4n plus 4 equals 9n. So this will be n square minus 5n plus 4. Now this is quadratic equation. Now see here, quadratic equations are very important because these are so important equations in math that you have to use these equations in almost all the chapters, all the units. Okay, that's how important these quadratic equations are. Okay, so here it's going to be n square. I'm splitting the middle term. Okay, so it's going to be 4n minus n plus 4 equals 0. It's going to be n minus 4, and here n minus 4. So n minus 4, n minus 1 equals 0. And from here, value of n is 4 and value 1, right? So we got n4, we got n1. So what does it mean? It means that log of x to the base 1 by 3 is 4, and log of x to the base 1 by 3 is 1. Okay, so from here, what's going to be the value of x? So x is going to be 1 by 3 raised to the exponent 4, and from here x is going to be 1 by 3. So it's going to be 1 from here, 1, and from here it's going to be 1 by 81. So x is going to have two values, 1 and 1 by 81. Okay, so I hope it's visible to you. Yeah. Okay, so that's how you have to, here it's going to be 1 by 3 and here 1. So it's going to be 1 by 3 and 1 by 81. Okay, because see here, this is log of, see here how I did it. This is log of b to the base a equals to x. So it implies and implied on that ax equals b. So I just made use of the same thing here, right? Okay, now that's how you have to do it. Now let's move to the next one. Okay, so move to question number 2, and we'll see what's given to us. Question number 2 says that 2 log of root 5 to the base x square minus 3 log of root 5x plus 1 equals 0. Okay, so this is question number 2 given to us. Now, How to approach to this problem? Now, frankly saying that if I look at this problem looks quite a bit, it looks quite easy to me. Why? Because uh, if you assume this complex term to be some variable quantity or some abstract symbol, then I think we are on the right track and we can get to the solution. Why? Because it's going to be, for example, 2n square minus 3n plus 1 equal to 0. So it means we get quadratic, right? So here I can say put log root 5 base x equals to n, right? So which implies 2n square minus 3n plus 1 equal to 0, right? And from here, so we have to split the middle term, 2n square minus 2n minus n plus 1 equal to 0. Here, take 2n common. Here, n minus 1 minus 1, n minus 1 equal to 0. So here, 2n minus 1, and here, n minus 1 equal to 0. So here, n is going to have a value 1 and 1 by 2. Right? So now we have value of n and we have to find the value of x. So from here, log root 5x, it's going to be 1, and log root 5x is going to be 1 by 2. Okay, so from here, x is going to be from here x is going to be 1, right? It's going to be root 5, and here x is going to be it's going to be 1 by 2. Now n 1 and 1 by 2. So from here no, that's wrong. So from here, x is going to be root 5, right? And from here, x 1 by 2 equal root 5. So it means x is going to be 5. So we have x root 5 and x 5. So x is going to be root 5 and 5. Okay. Now you can check here because this is the base, right? This is the base. So base is going to be 5, root 5. Okay. So it's fine because the base should not be 1 and it must be greater than 0. So x is going to have the value root 5 and 5. Okay. So that's how you have to approach this problem. Okay. Now let's move to the next. Let's move to the next. Question number 3 says that we are given with the log of 100 x to the base 10 square plus log of 10x to the base 10 square equal to 14 plus log 1 by x to the base 10. Okay, so This is the next problem given to us. Okay. Now, if you look at the left hand side of this problem, especially here, here, and here. Okay, so here what do we have? We have constant and we have variable, and here the same, we have constant and we have variable. Okay, so what I can do here is that, can I make use of that property log mn is equal to log m to the base a plus log n to the base a if mn has base a, right? Which is the product rule, right? So what if I, here what I will do is by applying the product rule. And what was the product rule? It was log mn to the base a is log m to the base a plus log n to the base a. Okay, so if you apply the product rule, what will you get? It's going to be log log of 100 to the base 10 plus log of x to the base 10, right? And here square plus, again here the product rule, so it's going to be log of 10 to the base 10 plus log of x to the base 10 whole square, right? And on the right side, I can write 14 plus log 10 1 by x. I hope this is clear to you. We did nothing here. What I have done is that here I assumed it to be m multiplied by n, and then I applied the product rule in both the terms. Okay? Now, here, this thing can further be written as, now see here, this 100 can be written as 10 square. If I write here 10 square, then it's going to be 2 log 10 to the base 10. Why? I have made use of the property log x, okay? Log x raised to exponent n is n log x. So I have just made use of this property here, okay? And then here you have log x to the base 10 whole square plus here. Now here again log 10 to the base 10 plus log x to the base 10 2. Now see here, now it's time to observe something. Here we have log x to the base 10, here log x to the base 10, and here 14 plus. Can we do something to make here log x to the base 10? Now, what if I write this term as x raised to exponent minus 1, and then if I apply power rule here, then it's going to be 14 minus, log x to the base 10, right? See here, 1 by x can be written as x raised to exponent minus 1. So this minus 1 will come out and get multiplied with log x to the base 10. That's what I did. Now, see here, now we have log x to the base 10, x to the base 10, x to the base 10. Fine. And here, log 10 to the base 10, log 10 to the base 10. Now, log b to the base b is 1. So it's going to be 2 plus log x to the base 10 square plus, again this is 1 plus log x to the base 10 square 14 minus log x to the base 10. Now we can assume, let's assume that log x to the base 10 is n. Okay, so it's going to be 2 plus, it's going to be 2 plus n square plus 1 plus n square equal to 14 minus n. Okay, so it's going to be 4 plus 4n plus n square plus 1 plus 2n plus n square is equal to 14 minus n, right? So from here it's going to be n square, 2n square, okay, 2n square and plus 6n, right? 6n and plus 5 is equal to 14 minus n. So it's going to be 2n square plus 7n minus 9 equal to 0. Okay, so 9 times 2, 18. We have to split the middle term, 2n square plus here minus 2n plus 9 and minus 9 equal to 0. So 2n common, n minus 1 plus 9 and minus 1 equal to 0. So again, what we will get from here, n minus 1, and the factors are going to be n minus 1 and 2, n plus 9 equal to 0. So n is going to be 1 and minus 9 by 2, right? And our assumption was, now come to the point. So here log x to the base 10 is going to be either 1 or and log x to the base 10 is going to be minus 9 by 2. So what's going to be the value of x from here? X is going to be 10 and x is going to be 10 raised to power minus 9 by 2, right? So x is going to be 10 and 10 raised to power minus 9 by 2. Okay, so this is going to be your answer, right? I hope this is clear to you. Okay, here we did nothing. We just made use of ax equals b. So if this is log of x to the base a equals b, then you can just make use of a raised to exponent x equals b. So here x is going to be 10 and here x is going to be 10 raised to power minus 9 by 2. Okay, or it's going to be 1 by 10 raised to power 9 by 2. Okay, so that's how you have to do this question number 3. Okay, I hope it is clear to you. Okay, now let's go to number 4. Let's go to number 4. Question number 4 says that, let's see, what does it say? Question number 4, it says that x raised to log x to the base 10 plus 5 over 3 is equal to 10, 5 plus log x to the base 10. Okay, so this is question number 4 given to us. We are given with two numbers. One is on the left, one is on the right. Now, see here, what I think here is that here we are given with two numbers, right? This is on the left, this is on the right, okay? So what we can do here is that when we know one thing, that when two numbers are equal, then if we take log both sides, then their log are going to be equal to, okay? So if we take taking log both sides, okay, what would happen if we take log both sides? So log here, I will take log to the base 10. Why? Because here I have log base 10, right? So because I assume that if I take log base 10, then maybe in the end we are going to get some terms, and then maybe some cancellation would take place, or maybe we could make use of some property, okay? So here log of log of wait log of this thing x, here log of x to the base 10 plus 5 by 3 base 10 equals log of 10 raised to 5 plus log x to the base 10 divided to the base 10. Okay, now yeah, okay, now here what I can do here now is because this looks quite similar to log of x raised to power n, so we can assume this whole thing as n, right? So it's going to be n log x, and here same, we can assume this whole thing to be n, so it's going to be n log x, right? So we will make use of this property both sides. So what we will get here is, so this will come here, so it's going to be log x to the base 10 plus 5 divided by 3 multiply by log of x to the base 10 is equal to 5 plus log x to the base 10 multiply by log of 10 to the base 10. Now see here, log of b to the base b, this thing is going to be 1, right? So here what will be left here, and here what can we do? Can we do something here? Log of log, okay, first write it down, log of x to the base 10 plus 5 by 3 into log x to the base 10 is equal to 5 plus log x 10, because this thing is going to be 1, because log of b to the base b is 1. Now if you look at this thing, now I think we cannot do anything about it, but if you observe something here, you can see that we have log x to the 10 here, and log x to the 10 here, and log x to the base 10 here, okay? So we can assume this thing to be something, right? So here put log x to the base 10 equal to n. So this is going to be which implies n plus 5 by 3 multiplied by n equal to 5 plus n, right? So this thing is going to be n square plus 5n equal to 15 plus 3n, and it's going to be n square plus 2n minus 15. Am I right? Plus 5n equal to 15. And this is 0. Now, can we split the middle term? I guess yes. N square plus 5n minus 3n minus 15 equal to 0. Okay, so you come this side, it's going to be take n common, n plus 5, and from here minus 3 common, and here n plus 5 too. So our factors are going to be n plus 5 and here n minus 3. So from here value of n is minus 5 and here 3. Okay, now what did we assume? So log of x to the base 10, it is minus 5, and log x to the base 10 is going to be 3. Okay, so from here value of x is going to be it's going to be 10 raised to power minus 5, and here it's going to be 10 raised to exponent 3. So x is going to be 10 raised to minus 5, and x is going to be 10 raised to 3. Okay, so yes, so if we put x, yes, okay, so both the values are accepted here. Okay, so you will get x 10 raised to the exponent minus 5 and 10 raised to the exponent minus 3. Okay, so that's how you have to approach and solve this problem. Okay, let's move to the next. Okay, so if you know some other way to do the problem, see here there are numerous ways to solve one problem. Okay, so what matters is that how you approach the problem, how you break complex problem into the simpler ones. Okay, that's what mathematics is all about. When what we do in mathematics, if you look at all the steps, then you will see that in each step we are just simplifying the things. Okay, so simplification is the beauty of mathematics, right? Now let's go to question number 5. It says simplify. Now see here, simplify. So 2 raised to 2 log 3, and here raised to 3 log 4 base 3. Okay. Now see here, this seems so complex because it is raised to the exponent, and that has log in the exponent, and it is again raised to the, and the number in the log is again raised to the exponent, and that again has log in it. Okay, now if you look at this thing, see here, if you look at this thing, I can do something about this thing. Okay, what I can do about it is, see here, this is 3 raised to power 3 log 4 to the base 3. Okay, what I will do here is that, what if I bring it here? Okay, so it's going to be 3 log 4 raised to exponent 3, here 3, because we know that and log x is equal to log of x raised to power n. That's what I did here. Now this is a raised to exponent log b base a, which is b, means that here it's going to be 4 raised to power 3. Okay, so this will be simplified to 2 raised to power 2 log 2, and here 4 4 raised to power 3. 4 raised to power 3. So in short, it is going to be 2 raised to power 2 log 64 to the base 2. Right? Now, again, what I can do here is that, what if I bring this 2 here, okay, on the power? Okay, so it's going to be 2 raised to power log 64 raised to 2, and here to the base 2. Now this is same as a log b to the base a, which is b. Okay, so this thing is going to be 64 square. Okay, so your answer is going to be 64 times 64. So what is 64 times 64? This is 16, 25, 6, 9, 10, 4096. Okay, so this is going to be your answer. Right? So that's how you have to approach this problem. See here, it may look complex, but if you know the properties, if you know how to approach the problem, if you try to find some pattern that resemble the property, use it. Okay, so now let's go to the next one. Let's go to the next one. The next one says, number 6 says that, question number 6 says that radius is log a squared to the base 10 and circumference is log b raised to exponent 4 to the base 10, and we have to find log b to the base a. Okay, now the radius of the circle is given to be log of a squared to the base 10. The circumference of the circle is given to be log b raised to the power 4 base 10. So we have to find, what we need to find is find log b to the base a. Okay, so let's see, because we are given with the circumference, right? So circumference is going to be log b raised to 4 base 10, and the circumference is 2 pi r, right? So it's going to be log b raised to 4 base 10. Now see here, it's 2 pi. What's the radius here? Radius is, it is log a square base 10 is equal to log b4 base 10. Right? So what we can do here, is we need to find, okay, we can do one thing here. This is log x raised to power n, that is n log x, and it is also log x raised to power n. So we can write it 2 log a to the base 10, and here we can write 4 times log b to the base 10. So 2, 2, 4, 4. Okay, so now what we need b to the base a, right? So what I can do here is pi is equal to, bring this thing here, it's going to be log b to the base 10, and here log a to the base 10, which is equal to pi. Now see here, this is log m to the base a by log n to the base a is equal to log m to the base n. What property? Base changing theorem. So it's going to be log of b to the base a, right? So which implies log b to the base a is equal to pi. Simple, right? So see here, base changing theorem, it is going to be the game changer, right? So properties are very important and useful. Okay, now let's move to number 7. Let's move to question number 7. Question number 7 says that log of 2x plus x minus 41 to the base 10 equals x multiply 1 minus log 5 to the base 10. Okay, now this thing is given to me. Now what I can do here is, now see here, here I'm given with the log, here I'm given with some value of this log, right? So what I can do here is, I cannot do anything. If I try to open it, then what I can do here, no, I cannot do anything, but I can do one thing. This is written in log form. So what if I change this into the exponential form, right? So the exponential form, it would be 10 raised to x 1 minus log 5 to the base 10 equals 2x plus x minus 41. Okay, now see here, now I can do something, because now here I have 10 raised to x. Okay, so what if I write it as 10 raised to x, and here it's 10 raised to, and here I can write 10 raised to log 5 raised to x base 10. Why? Because this x will get multiplied inside, and here x log 5 base 10 can be written as log 5 raised to x base 10. Okay, so I hope you agree with me. Now what I will get from here is that, now see here, this is a a raised to power log b base a, which is going to be 10, right? Which is going to be 10. So it's going to be 10. So here 10 raised to power x, and this thing is going to be 10, and here x minus 5 raised to x 5 raised to x. Hold on. We are doing something wrong here. 10 raised to x. Hold on. 10 raised to x. 10 raised to x. And here 10 raised to, can I write 10 raised to x minus x log 5 to the base 10, right? So it's going to be 10 raised to x, and here 10 raised to log 10 5 x, right? Yeah, it's cool. Equal 2x plus x minus 41. So this is, now see here, this is a raised to log ba, which is b. Okay, so this thing is going to be 10 raised to x divided by 5 raised to x equals 2x plus x minus 41, right? And this thing is going to be, because the powers are same, so it's going to be, this is going to be 2x equals 2x plus x minus 41. Cancel, x equals 41. Understand? So that's how you have to do it. Okay? So the value of x is going to be 41. I hope you got it. Okay? Now move to the next one. Move to the last one. The last question, question number 8, and it says that modulus of x minus 3 raised to 3x squared minus 10x plus 3 equals 1. Okay, now this is given to me. Okay, now if I look at this problem, see here, this may look complicated, but I just know one thing, that log of 1 to the base 10 is equal to 0. And if somehow I make here log 1 to the base 10, and then I will reach somewhere. Okay, so what I can do is that if I taking log both sides, because log of 1 to the base 10, it's 0. So both sides I will take log base 10. So it's going to be x minus 3 raised to modulus, and here log 1 to the base 10. So log of x raised to power n, it is n log x, 3x squared minus 10x plus 3 log of modulus x minus 3 base 10, it's equal to 0. Okay, now I have two things. So either this is 0 or this is 0. Okay, so if this is 0, so what would happen? 3x squared minus 10x plus 3 is equal to 0. If this is 0, then what I will do here, log of modulus x minus 3 base 10 is equal to 0. Okay, from here, if I factorize it, so what's going to happen? 3x squared minus 9x minus x plus 3. So here 3x x minus 3 minus 1 x minus 3. So x is going to be 3, 1 by 3. Okay, now if you put x3, this thing is going to be 0, and this thing here is 3 square is 9 times 3, 27 plus 3, 30, and here 10 times 3, 30 minus 30. So you will get something like this whole thing will be like 0 raised to power 0, okay? And this thing is not defined. So it means that we have to reject this value, right? Because if you put this value, the left hand side will take the form 0 raised to the exponent 0, which is not defined. So if we put 1 by 3, then it's fine, right? And from here, now see here, from here, what would happen? 10 raised to power 0, it's going to be mod of x minus 3. This is 1. So mod of x minus 3, it's going to be 1. So what does it mean? It means x minus 3 is going to be 1, or x minus 3, it's going to be minus 1, right? So from here, x is going to be 4, and from here, x is going to be 2. Okay, so 4, yes, and 2. 2, yeah. So x is going to have the value 1 by 3, 2, and 4. Okay, we cannot take 3 because if you put 3 here, then we will get left hand side in the form of 0 raised to 0, which is not defined. Okay, so that's how you have to approach this problem. Okay, so you can take any number of problems related to logarithmic equations. Just you need to understand the problem, and then you have to, the most important thing is that how you approach the problem. Okay, like what's your mindset? Because for example, now I saw this problem. There are lots of ways to get to the conclusion, right? Because see here, the other way I can think is that this can be, a raised to power x equal to 1. Now, so see here, this is of the form a raised to power exponent x equals to 1. So what does it mean? So it can only be 1 if x is 0, right? If x is 0, okay? So from here, I can put x equal to 0 and I can get this value, okay? Or the other thing would be if the base is 0, right? So there are lots of ways, because here you are given with the modulus, okay? So you can put this thing to be 0, okay? You can put this thing to be 1, not 0, 1. You can put this thing to be 1. So if you put this thing 1, so see here, 1. So there are lots of ways, but when I saw this one, I thought the first thing that came to my mind is that, oh, log of 1 to the base 10 is 0. So if we do something about this, then maybe, we will get somewhere where, reaching solution gets easier. Okay. So, how you approach the problem is very important. So I hope this thing helped you, and I will see you soon in the next session. So until then, take care of yourself. Bye bye. Thank you very much.